Alright, welcome again in another tutorial of the topic differentiation. In this tutorial, we're just going to see the derivatives of inverse of trigonometric functions, like when y equals to sine of inverse of x, or y equals to cos of inverse of x, or y equals to tan of inverse of x. In these cases now, what is dy dx? So let's start with this one, y equals to sine of inverse of x. Let's find the dy dx. So I know that this is just the same as x equals to sine of y, because now y is just the inverse, the sine of inverse of x. So here I can find the x dy. This will just be equal to cos of y. But I'm looking for dy dx, not the x dy. So if I can just reciprocate both sides. This becomes dy dx over 1 cos y. But I know that sine squared of y plus cos squared of y is equal to 1. So, if I just make cos y the subject there, it's just going to be equal to the square root of 1 minus sine squared of y. So, my dy dx is just going to be equal to 1. Now, instead of cos y now, I write this one. This is 1 minus sine squared of y. But I know that sine y equals to x. So x squared is equal to sine squared of y. So my dy dx will just be equal to 1 over the square root of 1 minus x squared. So this is dy dx when y equals to sine of inverse of x. Okay, so let me try and solve an example now. Let me see an example. Let's solve this example. It says, call this example 1. Find dy dx if y is just equal to sine inverse of x squared. So hapa natokaje? Nitatumia chain rule. So I'll just let w equals to x squared. So y is just equal to sine of inverse of w. Then dy dx by chain rule will just be equal to dy dw times dw dx. So kutoka hapa sasa, hapa kwenye w sasa na x squared nitapata dw dx ambayo itakuwa ni 2x. Lakini hapa sasa kwenye y is equal to sine of inverse of w. Okay, my dy dw will just be equal to, kumbuka y is equal to sine inverse of x, tusema ni 1 over the square root of 1 minus x squared. Kwa hiyo itakuwa ni 1 over the square root of 1 minus w squared. So now, my dy dx tumesema ni sasa na dy dw times dw dx. So what's dy dw is 1 over the square root of 1 minus w squared times the w dx tumesema nini? Ni 2x. But what was w? W is just equal to x squared. So w squared is just equal to x power 4. So my dy dx is just going to be equal to 2x times 1 is 2x over 1 minus x power 4. You see? Kwa hiyo ndo inverse of sine, derivative for the inverse of sine. So hilo ni swala example moja nimeifanya, and this is the answer I get. Now let's see for y equals to cos of inverse of x. What is dy dx? So I know here x is just equal to cos of y. Okay? ndo maana yake trigio. So I mean I can find dx dy. So if I differentiate cos y with respect to y, napata negative sin y. Tulisoma kule nyuma. So I'm looking for dy dx, not dx dy. So na reciprocate both sides. Huku nitapata negative 1 over sine of y. But I know that sine squared y plus cos squared y is equal to 1. So I mean making sine y the subject there, sine y is just going to be equal to the square root of 1 minus cos squared y. So I mean dy dx now is just equal to negative 1 over the square root of 1 minus cos squared y. But what is cos y is x. So cos squared y is just x squared. So dy dx is just going to be equal to negative 1 over 1 minus x squared. Kwa hiyo hii sasa ndo derivative ya cos inverse x with respect to x. Okay? Kwa hiyo kama vile tulivyokuwa na derive ya cos x tukapata, ya sin x tukapata, so na sasa tumederive ya sin inverse x tumepata, cos inverse x tumepata. Okay? Unaweza ukaikariri, japo hizi ni ngumu kidogo kuzikariri. Inawezekana ikakulazimu derive kila mara unapokutana na hili swali. Lakini ukifanya mara nyingi, nafikiri unaweza pia ukakariri. Ukakumbuka tu, so ukakariri. So this one is cos inverse of x. Now let's solve an example. Okay, so let's call this example 2. It says find dy dx if y is equal to cos of inverse ax, where a is constant. So natokaje hapo? Again, I'm going to use the chain rule, okay? I'm just going to let w equals to ax. So y is equal to cos of inverse of w. So dy dx will just be obtained from chain rule, dy dw times dw dx. So I can get from this one, from w equals to ax, I can get dw dx, which is going to be equal to a. Sasa, and then y is equal to cos inverse of w. Cos inverse of x nisema ni negative 1 over the square root of 1 minus x square. Kwa hiyo hapa bila shaka dy dw is just going to be equal to negative 1 over 1 minus w squared. So, chain rule sasa. Nimesema from chain rule, dy dx itakuwa ni sasa na dy dw times dw dx. Kwa hiyo dy dw tumesema ni negative 1 over the square root of 1 minus w squared times dw dx tumesema ni a. But what is w? W is a is x. So w squared is just equal to a squared x squared. So my dy now dx finally just be a times negative 1 gets negative a over the square root of 1 minus a squared x squared. So this is the answer for is a derivative for the cos of inverse of ax, where a is constant. Ndio hiyo hapo, huo ni mfano nimefanya. Okay, sasa tufanye kwa ya tatu. Ya tatu ni nini? Tan. Y equals to tan of inverse of x. Hii maana yake nini? Dy dx kwanza tunapataje hapo? Okay, ndo tunafanya sasa dy dx tunapataje. So x is just going to be equal to tan of y. So this simply means x is equal to sine of y over cos of y. So this is like a quotient of polynomial functions. So I'm going to use the quotient rule to find dx dy. I'm just going to use the quotient rule, v du dy minus u dv dy over v squared, where v ni cos y, okay? So v is cos y and the u is sin y. So dv dy is just negative sin y, wakati du dy is just cos y. So my dx now dy is just gonna be equal to v ni ile kule cos y, du dy tena ni cos y, minus u ni sin y, alafu dv dy ni negative sin y. Then chini tuna cos squared y. So kule juu nitabaki na nini? Nitabaki na cos squared y plus sin squared y over cos squared y. Hii jumlisha hii ni moja. Kwa hiyo dx dy is just equal to 1 over cos squared y. Kwa hiyo dx dy ni sasa tu na nini? Na sec squared y. Lakini kumbuka nilikuwa natafuta dy dx, sio dx dy, kwa hiyo na reciprocate kote. Napata hapa ni 1 over sec squared y. Lakini najua sin squared y plus cos squared y sasa na moja. Kwa hiyo nagawanya hapa na cos squared y, na hapa nagawanya na cos squared y, na hapa nagawanya na cos squared y. Inaruhusiwa, okay? Sasa na times na 1 over cos squared y everywhere. Kwa hapa nitabaki na tan squared y plus 1 is equal to sec squared y. Ala, kumbe sec squared y ni sasa na 1 plus tan squared y. So my dy dx is just equal to 1 over, instead of sec squared y now I write tan squared y plus 1. But what is tan squared y? But what is tan y? Remember x was equal to what? To tan y. So x squared is equal to tan squared y. Kwa hiyo tan squared y is just x squared. So my dy dx now is just going to be equal to 1 over 1 plus x squared. Kwa hiyo hii sasa ndo derivative ya nani? Ya y equals to tan of inverse of x. Derivative yake ndo hiyo. Kwa hiyo na hii na yenyewe tume derive. So let's solve one final example ambayo itahusiana na hiyo tan. So check out now this example. It says, I will call this example 3. It says find dy dx. Okay? If y is equal to x squared, tan of inverse 4x. So look, I have this one and then I have this one. So I can use the product rule, okay? Product rule nasemaje? Dy dx is just going to be equal to v du dx plus u dv dx. Hii ni for y equals to uv. Kwa hiyo hapa our u is just x squared. So our du now dx is just 2x. And our v is just equal to tan of inverse of 4x. Well, I am afraid hapa itabidi nitumie chain rule. So I'm going to let w is equal to 4 of x. So, I mean, my dv dx by chain rule will just be equal to dv dw times dw dx. You see? Here my v will just be equal to tan of inverse of w. So now from hapa dw dx itakuwa ni 4 tu. Sawa? So dw dx ni 4 times hapa dv dw itakuwa ni 1 over 1 plus w squared. Kwa hiyo ndo nini? Hii ndo dv dx. Sawa? Yeah, I mean here dv dw is just this one, okay? But w is equal to 4x. Kwa hiyo w squared, kwa hiyo dv dx sasa itakuwa ni sasa na 4 times 1 ni 4 over 1 plus, nikisquare both side hapa napata w squared, hapa napata 16x squared. So this one is dv dx. Sasa isikuchanganye hapa, w equals to 4x, dw dx nimepata 4. Sawa? Na isikuchanganye hapa, hii kumbuka derive tan inverse x ni 1 over 1 plus x squared. Kwa hiyo hapa ni w sasa, sio x, so imekuwa hivyo. But w is 4x. So squaring it, I just get 16x squared. So this one is my dv dx, this was my v, this is my u, and this is my du dx. So I can now use the product rule kwa Ramstar. So my dy dx now dx will just be equal to v, which is tan inverse of 4x, times du dx, which is 2x, plus u, which is x squared, times 4 over 1 plus 16x squared, which is dv dx now. So what do I get? I get that dy dx is going to be equal to 2x tan inverse 4x plus 4x squared over 1 plus 16x squared. Kwa hiyo ndo derivative ya lile swali letu lilikuwa nini? Swali letu lilikuwa y sasa na sasa na not tan, sorry. Sasa na x squared tan inverse 4x. Kwa hiyo jibu lake ndo hili hapa sasa. So I think it's enough for that. See you in the next tutorial.